Hey Rami, hey Joshua.
Hi Vinod.
Hey Brendan. I think we are early. Yeah.
Hey, everybody.
Hello.
You had a few minutes for some folks to join. Yeah, everything's working, Jory. Thanks for setting up.
Well, y'all let me know if you need anything. Talk to you in Slack.
Sure.
Right.
Sounds good. Thanks. All right, give it maybe one more minute if other folks join, and we can get started. Let me go in.
Good morning, everyone.
Good morning. We're just about to get started here. I'm just gonna forward on the for anybody who doesn't have it. Feel free to put your your attendance in the meeting list, and we have a couple of things. Obviously, today's the first meeting on the project, and we have a relatively simple agenda. But yeah, just feel free to put stuff on there. And while everybody is doing that, I'll give a quick introduction, and then we can kind of go around the room here, and then go through the agenda. So I'm Mike Lieberman. I'm a supply chain security engineer over at Citi. I guess a couple of months ago, or rather a while back, a bunch of us at Citi and our partners had sort of written up some code as sort of tying together a lot of the cloud native CI things in order to sort of implement what was being written up by the CNCF. The CNCF has their Secure Software Factory reference architecture, which is going to be, I think, officially released at KubeCon in a few weeks. And we wanted to sort of start implementing some of the stuff that was being written up in the draft, as well as following the various best practices. And so that's where this sort of project came about. And so yeah, and then after a while of sort of interacting with the various groups like the OpenSSF and CNCF and whatnot, the supply chain integrity working group here at the OpenSSF had, said that, hey, this might be a good spot if we wanted to make it sort of, if we wanted to contribute that to an open source group. So yes, this project has been contributed to OpenSSF underneath the supply chain integrity working group. And yeah, so that's sort of the brief introduction there. And I guess we can sort of go around here. I know a lot of folks are from City as well, but I see next on my sort of thing there is David.
Yeah, well, I think actually we're supposed to start with welcome new friends, except that technically we're all new friends, right?
Yes, yes.
So, so Mike, are we going to just move right on to the next topic on the purpose?
Sure. If folks, I was just curious if folks wanted to maybe introduce themselves. If we wanted to just sort of have some folks introduce themselves, just so if they want
Sure.
to, so we know who's joined.
Yeah. We don't know who is David. So maybe.
Sorry. Well, yeah, actually, I don't know if everyone does. So if you don't know, David Wheeler, I work at the Linux Foundation. I'm here to try to help these various projects, do all the great stuff they're trying to accomplish. So I'm here trying to be helpful. So if I'm not helpful, just let me know and I'll try to swing something else or help in some other way. Does anybody else want to introduce themselves?
I will go next. So I'm Vinod. I'm also from City, working along with Michael and others on the call. I think we have majority of City people on this call. So yeah, also participating in almost all other OpenSSF working group calls and the other calls. Yeah.
I guess I'll go. My name is Eric Smalling. I am a senior developer advocate at Sneak on the container and cloud native side, and coming here basically to make sure I have my finger on the pulse of what's going on and help out wherever I can.
All right, I'll go next. My name is Greinhofer. I'm a software engineer at City. I work in Michael's team.
And I can go next. Sorry, go for it.
It's okay. Hector Fernandez. I'm a secure supply chain engineer at VMware.
My name is Maor. I'm from White Source. I'm leading the product for cloud native solutions. I just came here to see how I can help and get on track on things.
Hey, my name is Brad Beck. I work at on the supply chain security group at City also. I've been working on the secure software factory for a few months now, focusing quite a bit on the queue side of things. So doing configuration and validation sorts of things there.
I'm Brandon Mitchell, work with Boxboat, who got acquired by IBM, and I've been working with Michael and his team on the Ssf project lately.
Hi, I'm Parth. Also part of Boxboat IBM now, working with Michael and the City team on a secure supply chain. Glad to be here. Should be a good time.
So I'm Arnaud Loors from IBM. I didn't just got acquired. I've been at IBM for over 22 years, but welcome, guys. I'm an open source, open standard specialist, and I've been involved in OpenSSF for a bit more than 6 months now. And a bit like David, I'm here to help. I mean, IBM invested in OpenSSF as a, and so my goal is to make it a successful community.
Maybe I can go next. Fatih Dermenci from Ericsson Software Technology, open source developer, contributing to Continuous Delivery Foundation, various efforts relate this SSF, contributing to special interest group software supply chain there, and looking for cross-community collaboration opportunities.
Am I the last one?
Just go ahead.
Yes, so I'm Liora Milbaum. I'm from Red Hat, acquired by IBM a few years ago. I'm a product owner for the Red Hat in-vehicle operating system supply chain. And I'm also co-chairing with Fatih one of the CDF SIGs. And I'm here to contribute. Already started, so thank you guys for reviewing my PRs and helping me to get on board.
Cool. Oh, I see a few other folks joined.
Yeah. I'm Josh. I work on Mike's team, city software engineer, and yeah.
I'm Tim Miller. I'm one of the many city folks. I also did work at IBM like 19 years ago briefly, so I think I've touched all of the major companies here.
Sorry guys for being late. I'm Michael Commerce from SNCC. I'm working in the SNCC city office, investigating supply chain security. Good to see some of the folks here.
Cool. So just want to make sure we don't leave anybody out here. I notice there's still Marta, Sandipan, and Ava.
Oh, folks. Ava Black, Microsoft, also on the OpenSSF TAC, and it's great to see a bunch of familiar faces. Michael and Brandon and other folks coming over from this similar or possibly same meeting series in the CNCF.
Cool.
Yeah, I am Sandipan from Red Hat Incident Response team and handling the product supply chain also. So yeah, thank you.
Cool. All right. So Marta has a bit of a phone issue. So I'm sorry, a microphone issue. So we'll just, I guess, get started here. So yeah, obviously, first meeting, trying to kind of work through some of the, let me just sort of go through a little bit of the purpose of the project for those of you who don't know. So there's two main purposes of this project. The first is to sort of build a secure implementation of a secure software factory. So by that, just a CI system with adequate sort of security controls and applying various security best practices, such that we can kind of do the right sorts of things from a supply chain security perspective. So that's both from like an ingestion standpoint of, hey, can we enforce that whatever we're bringing into our builds are things that meet our security policies, as well as whatever we're building. Are we tracing what's going on in that build? Are we monitoring what's going on in that build, so that we have some level of confidence that the build did what it was supposed to, and if it didn't do what it was supposed to, can we track can we track that and trace that? So that's one sort of big piece of it. The second big piece is, hey, given all of the various best practices from a project level of supply chain security, can we also use this project as a test bed to test out stuff like the Security Insights project coming out of OpenSSF, security scorecard, apply all the CNCF supply chain security best practices as much as we can. Can we start to kind of follow those best practices, see where perhaps there are gaps today that we need to then bring to the other groups and potentially other tools to help fill in some of those gaps. And, you know, based on you know, a lot of the documentation we've been writing, a lot of the best practices guides, white papers, etc., you know, are they proving to be adequate? Can we use this also as a bit of a case study? So that's kind of the two main purposes here. And to dive in a little bit on that first purpose real quickly, you know, there is you know, the purpose of also this project is to create a secure software factory that trying to think of the way to word this. You know, not every company can just use GitHub and GitLab actions, right? And for various reasons, you know, sometimes it's, you know, GitHub doesn't support, you know, GitHub Actions doesn't support a certain thing you need. Sometimes it is because of regulatory reasons, you know, you can't have it exist on a SaaS service, or you don't, you know, a lot of folks just have legacy systems, like, you know, and you just can't get on to GitHub or GitLab or whatever else, whether it's SaaS or you're running it internally. And so what sorts of things can we do today for folks who need a little bit more and need maybe some more of that customizability and so on and so forth? And so that's kind of one of the other reasons why this exists as well. And yeah, so with that said, any questions so far about the project or anything else?
So I have, at the risk of being terribly wrong, I thought might be useful to have a one-sentence summary. A lot of other projects do. So I took what you just said and tried to turn it into a sentence. It doesn't have to be right, but well, it may not be right, but I have tried to make it right. So do you see the one-sentence summary I just wrote down there? Did I capture it? Did I not capture it?
Yeah, I think by and large you captured it. I think the only thing that we try to sort of, we don't, there's two things. One is we don't want to give folks the idea that this is some production ready service or anything like that. But we also want to make sure that folks don't think that this is always going to purely be a POC. The idea should be that it is a sort of a baseline that maybe people can use to then build what they want. That's the only thing, just because I know from one of the things that some folks had warned was, like, if you start saying, oh, this is just purely a POC or this is purely a demo, then people just sort of always view it purely as the demo. So that was just it. But beyond that, I think totally makes sense.
Well, I mean, build a baseline implementation of.
Yep, that's perfect. Arnaud, you have your hand up.
Yeah, so let me ask a clarification here. I mean, is the primary goal to have a specific instance, or to define more like, you know, a playbook on how to set up your own secure software factory?
So it is an implementation. So let me share a little bit of the code here, and I'll kind of start walking through what it currently looks like today.
All right, thank you.
Sure. Can everybody see my browser here?
Yeah.
Yep. Cool. Yeah. So so what we were trying to do is we're trying to use all the sort of open source tools that are in the space. By and large, they're all underneath the Linux Foundation. So a lot of these are either under the CD Foundation or the CNCF. And in certain cases, we're actually looking to include a few things coming out of OpenSSF as well. But at a very high level here, actually, let me see if I can pull up. Well, I'll pull that up in a second here. But largely, if I click on platform here, so we're using, you know, Kyverno as an emission controller. We're using Tecton right now and Tecton chains for CI/CD. You know, we have some things that we've done in the past for using OPA Gatekeeper. But the idea behind it is we're looking, you know, so the idea here is there's a lot of different tools out there, like in the space for sort of securing CI, starting to do the supply chain stuff, whether it's SigStore or Notary or you know, from a policy standpoint, Kyverno and Gatekeeper and yada yada. And the idea is we're trying to sort of take build an implementation that integrates the various tools as they make sense into something that sort of ties everything together. So one of the big things here is, hey, if you just use Tecton, right, you're not necessarily doing the right things from a supply chain security perspective. So this thing is a combination of configuration as well as sort of higher level sort of tooling to tie all the various pieces together so that when you do deploy this thing, you're deploying it in a way where you have those secure defaults so that, you know, if you try to deploy a pipeline that, you know, doesn't match the policy, it just doesn't let you, right? And sort of that's kind of the purpose there. And I can show a diagram that kind of maybe explains it a little bit better. Give me 1 second here. Pull this up.
Mike, while you're doing this, I am attempting to capture what you're saying now as a problem statement, because I think basically you're going back and saying why you need such a thing, which is great, and I think that's basically a problem statement, which is, I think, often really helpful for understanding why you're building something.
Yep. Yeah. So I think the main yeah, if I were to sort of reword a lot of this, the main problem statement is, hey, there's a supply chain security problem. Folks don't know how to sort of build their software in a way where they can sort of where they have increased confidence that, you know, some source code on the left led to some artifact on the right, and that all the steps in between happened in the right order against those inputs, right? So that has been missing. And so I'm trying not to sort of just reiterate everything that's going to be in the cloud native, the CNCF documentation, but like largely the problem is how do we build our software where we can trace the provenance? And if we're tracing the provenance, then we have increased guarantees that the various steps that we're doing within that CI/CD process, stuff like SAS scans, DAS scans, generating SBOMs, yada, yada, are actually happening against the things that we expect them to be happening against. And if we're also applying the right security rules against that CI system, then we might even have increased confidence on, you know, if I'm running a Maven build, let's say, that Maven build is doing what I expect, right? It's not going out to malware.com and trying to download bad dependencies, right? Which is the concern. And so like, even today, one of the problems is like, hey, I have a security scan. Do I know that security scan actually ran against the artifact I expected it to? It can be quite difficult to sort of figure that out. And so even though we have a lot of the tools today to start answering these questions, stuff like, you know, Tecton and Tecton chains and, you know, admission controllers like Kyverno and OPA and stuff like, you know, SigStore and Notary for signing and all that sort of stuff, and Tough and all these things, there's really not a lot out there thus far, at least from our perspective, that has gone in and started to tie all those pieces together into something that is both cohesive and relatively easy to use, right? A lot of the stuff that has come out thus far has just purely been, here's a demo of a thing, and, you know, I have a custom policy for this, and I have a custom pipeline over here. And the idea behind SSF here is to sort of use that tooling to, and this is kind of the diagram I wanted to show off here, is by using the SSF tooling, what we can do is we can say that same configuration, and this configuration is using Q, and which is Q is a configuration language, which can export, Kubernetes YAML, it can export JSON, it can export, whatever. But the idea is we can generate a single specification. So when we deploy a pipeline, we can deploy along with that pipeline any sort of secrets and configuration maps, etc. We can deploy any specific configuration that Tecton Chains needs. We can also deploy runtime policy, so that if somebody comes in after the fact, has access to our Kubernetes or whatever, and tries to deploy out, let's say, a bad pipeline, well, if it doesn't match the policy, it just won't allow it to be deployed. And there's a whole lot of other stuff in there that I think is worthwhile, but more for a deep dive, maybe for next time or out of band. So does that sort of make sense?
I presume that just for demonstration purpose, there'll probably be a hello world or something like that to show that the whole thing works end to end.
Yep. We have actually several of those. So actually, I guess if folks are interested, I could just sort of run through some of that right now. It shouldn't take very long unless other folks had specific questions or anything like that. Okay, cool. So let me, in that case, just maybe go through some of the diagrams, and I apologize to anybody who is attending the my cloud native talk, because this is more or less the cloud native talk I'm gonna be giving here. Generally, this is what generally what a secure software factory is. So I'm going to talk about first the secure software factory, and then I'm talking about SSF, and we could also talk about naming and whatever a little later if folks have issues with the name. But generally, the secure software factory sort of takes the place of what you would imagine the CI/CD system is. So it essentially is the CI/CD system, just with various security controls and other things in place in order to make sure that, when I'm building something, am I actually building it securely, right? One of the common attack vectors, as we've seen with stuff like SolarWinds and whatever else, is, well, let me attack the CI system or the build system, the build environment, whatever, and that's how I sort of get in. And so the point of the secure software factory is sort of saying, okay, well, because a CI system, a build system is doing so many potentially arbitrary things, like compilation is a very complicated process. It can be very difficult to detect that something, suspicious is actually happening. So the point of the secure software factory is to really limit both the blast radius of what happens if there is a compromise, while also reducing the actual attack surface. And to be clear, I recommend, once it's been officially released, looking at the CNCF's reference architecture on this, because that really sort of describes it in depth on how a lot of this works. But at a very high level, it's mostly, the secure software factory pulls in code from source code control, pulls in dependencies from, your various artifact storage locations, does some operations on them and pushes them back out, right? Similar to CI/CD. The areas where it sort of differs is by having sort of a strong zero trust, by applying sort of zero trust principles, like, giving identities to all the stuff that is happening in the build. It lets you sort of say, well, okay, if this thing has, this thing has been permissioned to build the software, this thing has been permissioned to scan the software, this thing has been permissioned to generate an SBOM for the software, and so on. And then, that allows you to then sort of generate metadata and attestations around all of that information, sign all of your artifacts and all that good stuff. And then when you go to production, you can go and say, okay, great. Do I have all the valid signatures? Do I have all the valid attestations? If I do, I'm allowing it into production. If I don't, then something has gone wrong. Or if I see something that has been signed or there's an attestation, but the metadata in that attestation doesn't line up with the artifact I have. Hey, something went wrong. So that's kind of what the Secure Software Factory is. And I apologize for this this diagram here. I'll try and put in a better one later. But so this, when we kind of take when we go in a level down into what the Secure Software Factory is, like what's actually happening in the middle there. Well, in the center here, it's the core of what you would imagine your CI or your build system is, hey, I have one or more build environments, building code, running tests, scanning artifacts, whatever, right? And so if I go from sort of the right and then go around counterclockwise, what makes the Secure Software Factory maybe a little bit different than your average CI system, and to be clear, some of this stuff is stuff that some of you might already be doing or whatever, is, hey, I have a bunch of build environments. By applying sort of best practices of like all of your builds, your pipeline should all be as code, using something like a pipeline framework. In this case, with SSF, we're using Tecton and Tecton chains and all that, is, hey, that all lets us sort of say, well, I have pipelines as code, so I could always go back and look at that sort of thing. And some of you who've who've worked with sort of like the older versions of Jenkins, right? It used to be, hey, you had to go into a UI, click the buttons to create your build, and then anybody who had access to that server could potentially change the build, and it would be very difficult to sort of detect that. The idea here is, hey, we're trying to say, no, you must have build as code. Those are normal best practices, right? Great. But the things that we also are layering on top here is by also injecting an emission controller in, we can do stuff like, hey, if your team, organization, project says, we only support Java. Oh, you're trying to push out a pipeline for Go? Sorry, that's not going to work, right? Or if you say, hey, I'm going to push out a pipeline that pulls the latest tag. Sorry, we enforce a policy that says when you deploy a pipeline or you say, hey, I want to use this task, the images in those tasks must be pinned by hash. And in some cases, you could even say, hey, these images must be signed. They must have valid SALSA attestations, stuff like that. Cool. So that sort of helps explain how we're sort of looking at securing the actual pipelines and what is, and the definitions of those pipelines. But then how do we sort of secure what's happening within the build environments? Well, since a lot of this is all cloud native, right, we need to sort of first say, how can we secure how pods or containers are actually spun up? Well, that's where stuff like the pipeline observer and the attesters come in. So the pipeline observer here is just sort of like Tecton chains, right? We can't necessarily trust that a build environment itself is going to just sort of always report all the valid, its own information accurately, right? And so a pipeline observer is just sort of saying, hey, let me read the output directly. And so that provides some increased confidence. Now, obviously, a build environment could still do some nasty stuff to sort of fake that, but that's where the workload and node testers come in. And so the only ones I'm really aware of right now are sort of Spire, right? Generating SPIFFE identities. By generating these SPIFFE identities for these via these attesters, what we can begin to do is we can say, hey, when a build container spins up, so a Tecton task, right? When a build container spins up, there's two things that will start to happen. One is the node attester will sort of validate, hey, am I on a Kubernetes node that you own? It can attest that, right? Because if it detects like, wait a second, rather if Spire says, well, hey, wait a second, there's no, if a build container runs on a machine that Spire isn't running on or whatever, it's not going to be able to generate an identity for that build. And the same thing goes with workload as well, right? Where a workload can go and do stuff like, hey, Tecton says this build should be spun up with this container, with these parameters to the container. And so if something comes in the middle and tries to change that, it will no longer be able to sign that, right? Because it will no longer, the hash of essentially the hash of all the inputs to the container run will no longer match what is actually there. So you'll know, oh, somebody went in and tried to replace my container with a bad container, or to doing something else, will no longer sign it. Now, these sorts of things help out with sort of securing when I'm doing stuff at spin up time, right? But what happens if, let's say, hey, I thought I downloaded the right version of Maven and I'm running it on a container that I approve, but Maven maybe is doing something suspicious, right? How do I detect that? Well, that's where, another piece comes in, which is the runtime visibility piece. And so the runtime visibility piece here is stuff like, Falco or Tracy or similar sorts of tools that use, stuff like eBPF or other tracing technologies to actually introspect on what's happening inside the container itself. And by using those sorts of tools, we can begin to detect stuff like, hey, wait a second, why is my build trying to reach out to, some random, malware.com or something like that? Why is it trying to reach out there? That doesn't make sense. Let me alert on that and hey, that's suspicious. And then of course there's other things that are sort of fairly common things that malware often does, which is, hey, it injects additional sorts of things into memory and then tries to run that and, so on and so forth. And so there's a lot of these signatures of things that you can do to sort of record what a build is doing and sort of alert on that. And so while all of these things are happening, all of the metadata regarding what's happening inside of a build is being signed off on by the valid identities that are given to the individual tasks, to the individual steps, and so on. And all of this data is being pushed to sort of metadata storage, right? So these are SALSA attestations and so on. And where applicable, they're pushed to stuff like OCI or whatever, but they could also be pushed to transparency logs like Recore. They could be pushed to document databases like Mongo. It doesn't necessarily really matter there. But that, to be clear, is sort of what the Secure Software Factory is. Before moving on to the next one, does anybody have any sort of questions on that? Cool. So just to kind of go another level down of what a potential build process looks like, the idea behind the Secure Software Factory and SSF, the implementation that we have, is none of this should replace what you're already doing potentially from a security perspective, right? If you're still sort of, you're downloading code and your dependencies, you're probably running some linting, some scans, some security scans and so on. You're building an artifact, you're maybe then, scanning that resultant artifact and whatever, and then eventually you're publishing that artifact. Now, the thing, once again, to kind of tie it together is the stuff that SSF is trying to do is, because you are recording everything that's happening in each of these tasks, and as long as you're securing your control plane correctly and everything else, well, if I'm recording what's happening in each of these tasks, well, I can say I downloaded this code, this commit ID, the hashes of all the files are these. I can then record that, hey, this linter linted these hashes, right? If for some reason, these two things report different information, you can go back and say, wait a second, it said it linted this hash. When I actually got to the linting step, it said I downloaded this hash. When I went to the linting step, I actually got this hash. That's weird. That should not have happened, right? These are the sorts of things that, that help sort of detect where some of these issues are. And so on. And so, you should not stop doing your SAST and DAST scans. This just sort of helps you validate that the SAST and DAST scans you're doing, the SBOMs you're generating, are based on the actual stuff you actually downloaded, right? You know, that you expected to, right? So that's one of the things that has been a big issue in the past is somebody goes in and is like, oh, I thought I ran a security scan against the artifact I published to production, but it turns out it was a different thing and I hadn't known. So this is where now we kind of go into what the purpose of sort of how we do this in Secure Software Factory. In SSF, I should say. So in SSF, the idea behind it is, hey, a lot of what I described before, about 80% of it can probably be done in GitHub Actions, GitLab, and so on. And a lot of those things are building out new tooling every day. But as I kind of mentioned before, that's not going to work for everybody. So this is where sort of SSF comes in, right? And some of the stuff that we're starting to build out with SSF, with Q and QLang, which Brad, who's on the call, has done a ton of work on, is what we can begin to do is we can sort of say, hey, here's a set of SSF defaults. These are things that are these are things that like SSF views as these are the best practices for Secure Software Factory, right? So these are things that, if you break this, we can't obviously guarantee anything about the provenance. But these might be things like we enforce pinning of hashes, right? Of everything that goes through, right? If you don't pin the hash, sorry, we don't let you deploy a pipeline because, and to be clear, that's just an example. I'm not saying that's the actual route we're going, but that's a potential example there. So SSF provides all of these defaults. We encode those defaults in a specification in Q. And then you can imagine an organization might be something like CNCF or OpenSSF or whatever. And, CNCF might say, hey, look, we expect, I'm just going to throw this out there. I'm not saying this is actually the case, but CNCF might say, hey, we only support Go, Python, and Java. That's it. We don't support anything else, right? And okay, so at an organization level, you can begin to continue to constrain those things to say, yeah, we only support those 3 languages. So if somebody comes in with a new pipeline and says, hey, I want to use Rust, oh, sorry, we don't allow that, right? And to be clear, that's just an arbitrary example there. But the idea behind it is we want to make, because if you look at to some extent like how GitHub and a lot of the GitLab stuff works is it can get very complicated if you need to manage hundreds or thousands of pipelines. The idea behind a lot of what we're trying to do with SSF is, solve, also internal problems to our bank and so on, is like, we need to make it just as simple to solve one pipeline as it is to solve 1,000 pipelines. And so that helps us out here, right? So we can sort of say, hey, our organization, we enforce this kind of, we say we must generate Cyclone DXS bombs, right? We are gonna, that's our policy or whatever, right? Okay, great. So that's how we do it, right? We can sort of constrain it at the organization level, generate a queue specification, and if you come in and you try to include, for example, if you try and, let's say, take out a task from a pipeline that has your SBOM generation step, well, you can't deploy that because it doesn't match the specification. And then you can continue on down the sort of line here where an individual team might say, hey, yeah, sure. We, even though the organization allows Java, Python, Go, we only support Go. So our team is only a Go team. So if somebody comes in, tries to, create a new pipeline or whatever, it must be Go, right? And then the same thing goes down even to project level. So a project might say, hey, we're a new project, so we want to use Go 1.18 or above, right? And so we don't have any legacy. Great, you can encode that as like a further refinement of the specification. And so because of that, that helps sort of the ability to sort of manage lots and lots and lots of disparate pipelines while still applying all of these various rules in a clear and consistent way. And then that goes to the next step here, which helps us in actually deploying all of this out, right? So when I actually go to deploy this out, the same configuration generates the it generates the Kubernetes custom resources and normal resources, the YAML for Tecton chains, for Tecton pipelines, for Kyverno, for the various config maps and whatever else, and helps tie everything together, as opposed to saying, hey, every single time we create a new pipeline, I need to have a policy associated with that pipeline. No, this will actually say, no, we have a queue specification that automatically pulls it all in and then generates that. And so for the end user, if you're just sort of, let's say, hey, I just have one more Go pipeline. Okay, cool. Give me your, give me where your code lives, maybe the team name or whatever, and it generates the pipeline, right? And that's all you need to think about as the end user. So we're trying to also make it as simple as possible on that end. Okay, I know I talked a whole lot about a lot of different things here. Any questions about anything I've shown off?
I don't know if it doesn't count as a question, I don't think, but let's see here. One thing that I think you've been assuming, but I don't think it's been stated in the meeting here, is that I don't think there's an assumption or an assertion that the secure software factory is the only possible way to combine tools. It's simply a demonstration. You've been clear on that before, but I don't think we've actually said it here. So I want to just put that in the notes here somewhere so that people don't go away with that misunderstanding.
Yeah, no, and I also want to separate out the secure software factory, which is a reference architecture by the CNCF, which that's the CNCF coming together and saying it's a tech, and to be clear, the CNCF's secure software factory reference architecture is a technology agnostic, other than being cloud native focused, set of practices and whatever that is supposed to tie all of that together. And to be clear, SSF is just an implementation of that. But once again, yeah, any of these different pieces here could be replaced with other stuff. It's also not the only approach to the problem. It's just an approach to the problem, and an implementation of the problem. Sorry, and implementation to help solve the problem. Yes, but I agree. Like a lot of, I sort of mentioned before, 80% of this is stuff that I believe with very, very little effort can work out of GitHub and GitLab, and there's discussions I think around, I think a lot of this can be solved by different things in Jenkins X, and there's also OpenShift pipelines, which does some of this as well, I think in the latest version at least. And so there's a lot of different things that can begin to do this. I think the thing that we're trying to do is we're trying to really apply as many of the latest sort of practices and the latest tools and technologies, so that we can begin to solve a lot of the big problems there.
Okay, and a related one, which is products of this group. I made a swag, but I think it's consistent with everything you said. I mean, the goal is to produce both code and documentation. Code to implement and docs to kind of explain things, helping somebody to reuse the whole thing or parts and rationale and so on. Is that fair?
Yep, correct. Yeah. So the idea, like some examples of what we would love to be able to do as well is like, hey, we could provide as part of this example pipelines that go and say, hey, validate that all the dependencies that you're pulling in, or some set of dependencies that you're pulling in, have, OSSF scorecard ratings of at least a dot, whatever, right? Or, if it uses security insights, like, hey, validate that, there's this thing in the security insights. So like, these are the sorts of things that we're trying to also do to sort of make it easy for, end users to apply their policy to this sort of problem, right, in a way that is very clear, right? Because I think the thing that has come out a couple of times is just, it can often be, hey, I look at the security scorecard. How do I actually apply it? How do I actually look at a project and, is there a way to apply policy so that I know that when I'm looking at the scorecard, oh, if something, big shows up, I don't want to include that in my build or whatever.
Michael, I've got a question. I'm not sure it's in the scope of this meeting, but might be something that strikes me, this Q library, configurations library, policies libraries, or the language. Are you aware of work to kind of standardize this across the ecosystem?
What do you mean by that?
So are you aware, like, are there efforts, or should it be in the scope of this one? I know of, like, how these policies look like in the different tools. Because kind of the way I feel from looking at listening in many conversations, we've got all these different tools and ways to write policies and enforce policies. But what should the community do? Like when a company wants to implement those controls, is there a subset, or could there be a standard set of policies with its own specific domain language to implement?
Yeah. So by default, Q can support pretty much, or I'd say, other than a couple of bugs here and there, can support injection of any. It can support ingesting any custom resource. So we can actually support any Kubernetes custom resource by actually parsing the Go code and generating Q specification out of that. So that actually makes it very easy to just, as opposed to needing to write a specific handler for, let's say, I don't know, like for a Tecton pipeline, you could just sort of say, hey, here's the Tecton Go code, read its specifications there. And it can do it that way. Now, with that said, some of the tools that we've even been looking at, like Kyverno, I don't think they've made a decision yet, but they have been looking at stuff like Q as potentially as a policy language. The same thing also with some of the SigStore folks, I think, are also looking at QLang as a language as well. Kyverno, I believe, is looking at they're looking at Q, they're looking at JavaScript, and they're looking at a few other potential languages to manage that policy.
Got it. Thanks.
I see a question from Ava. Is the scope of the SSF working group assuming the presence of cloud native capabilities in the build process? So as of right now, I think yes, just because I think a lot of the tooling around this space, at least as far as I'm aware, and as far as I think a lot of my team is aware, the majority of work in this domain has been in the cloud native space. There are a lot of CI tools out there that are maybe a little bit more cloud native. They're not necessarily required to be cloud native. But these seem to be the most, at least from what I'm aware of, seem to be the most cutting edge, I guess. But if folks want to, help out with let's say some non-cloud native use cases, I think we're more than happy to sort of like collaborate on that. Does that answer your question, Ava?
Yes, thank you. And it opens up a corollary question. Is the intent of the working group to focus on encouraging the development of new tools to meet this sort of goal, or look at existing tools that already are already out there, that people are using to do this, and make some recommendations around them? And I ask that in the context in particular of any answers that we're giving to public policy or public recommendations. A lot of folks are looking at some of the past content that OpenSSF and others have produced and saying, well, that's a wonderful future vision, but what can I do today? And I'd just love to know the intent here. Is it the future vision or the today?
So I'll give my 2 cents, and then I'll let everybody else provide their input, because I don't want it to just seem like I'm the only person here. But I think from my perspective, I personally think both. I think, there's going to be things that I think we're going to see from stuff that is just sort of available. What I'm going to say is available today, but is cutting edge, right? A lot of the stuff that, to be clear, a lot of the stuff that's coming out of that helps SSF do what it needs to do. These are things that, were just merged in the past couple of days, right? And these sorts of things where for a lot of folks, could be 6 months or a year down the line, or maybe even longer before they can actually pull that in. So I think the thing that we're, what I would like to see is I would like to see a little bit of both. Like I would like us to see sort of, hey, this is what it could be. And then this is how things work today. And maybe here are the things we need to do today in order to make it close to what it could be. But I want to open it up to the floor here. If folks have other opinions on that. David?
Yeah. So I like the hey both. I would suggest to avoid the not invented here syndrome. Before building anything, look to see what's already out there. But I feel confident that once you start combining a large number of components, you'll discover something is missing. There are gaps, and so I think regardless of your druthers, you'll eventually end up trying to build at least some little things, either new tools or extensions. But I would encourage first look what's out there and then add what's needed.
Yeah, I'd imagine we all want to be as lazy as possible here in the best sense of the word, right? If something's already done this, don't do it again. But in all likelihood, I think you're right. When you put all the pieces together, this is a pretty complicated puzzle, and things are likely to pop up. But
and to kind of elaborate a little bit on that is, as much as is possible, I want to lean on the other projects in the community. You know, I don't want us to be the one saying, oh, you know, there's a gap in, I don't know, there's a gap in Tecton, so we're building a new version, you know, we're building a whole new thing. No, I don't want us to do that. I want us to say, hey, there's maybe a gap in this area. Is there a project already working on it? Is there a feature missing from one of the tools we've already integrated in? If so, can we reach out to that project and collaborate with them to fill in that gap, add that feature, and so on? And if there is a tool that's maybe completely missing, can we work with you know, the various groups that maybe that might make sense? And then if in the last, you know, sort of I don't want to say purely worst case scenario, but like I want it relatively lower on the priority list that we build it ourselves, let's say. Arnaud?
Yeah, so very much in that line. I mean, it sounds like you already have been working and developing something here. So how much do you already cover, and what are the obvious gaps that you want to go after next?
Sure. So we cover a lot. I think there's a few areas that, and I think the thing here I want to be clear about is, so we have collaborated with the Tecton folks in the CD Foundation. We've collaborated with Kyverno in, you know, the CNCF, and we've collaborated with SigStore and the OpenSSF and so on and so forth to help. Sometimes, you know, sometimes it's literally our developers, you know, building the feature, and sometimes it's, you know, us just sort of putting in a bug report or a feature request, and then, you know, collaborating to get that feature implemented. I think the thing here is that, you know, from my perspective, a lot of what we're doing is the glue that sort of ties the pieces together. And so where there are currently gaps today, and some of them are literally in the middle being filled, is, let me just, real quickly, because I know we're coming close on time here, but the Spiffy Spire work is stuff that was just very, very recently merged in and into sort of Tecton chains. And to be clear, you know, we would love to see other folks sort of doing similar sorts of things in this space. And so if there's areas where we can kind of make that clear to folks, that would be huge. And then another area that we are exploring is, hey, is there an open source Linux Foundation sort of tool that fits the runtime, that runtime visibility space? This could be something like a Falco, I don't know, but just, is there something there that we can start to use? Because currently we do not have this. Like, we've done a couple of POCs where, hey, I can run something locally recording a build, but we would love to sort of integrate that.
If I may add, a huge gap is, where's the documentation explaining all the piece parts and why they meet require? You know, I'm not opposed to diagrams, but the diagrams by themselves don't explain themselves.
Yeah. Yes. Okay.
Fair.
So
I'm not trying to tell you the baby's ugly. I'm just saying that there's a gap.
Yes.
I added one more comment in the chat to one more gap. Is the intent to provide a running instance of this, or a shovel-ready download to build this, or just guidelines? And the website also doesn't specify that yet.
Yeah. So I think these are some great things that I think I'm going to be creating a lot of issues after this meeting here. So as far as the documentation piece, once this has been officially published from the CNCF side, we will link to the Secure Software Factory to sort of say, hey, the Secure Software Factory is sort of a lot of the whys and and what tools should be there. And then this is sort of hey, this is just an implementation of that reference architecture. We have some documentation that is linked in here, but I do agree that we need to have a lot more in there to sort of explain significantly more on the why there. But yes, to your point, we will link a lot of that documentation. We'll also make a lot of that a lot clearer. And then to Ava's question, real quick, because I know we're at time already. So I think, first and foremost, we want to create something that is largely, I would say, like, shovel ready, but it's shovel ready in the sense of, hey, you want to sort of shovel ready from the sense of starting off, right? Maybe I would love one day for this to be a huge project that, anybody could just sort of pull off the shelf like a Jenkins or whatever and just sort of start working with. But I think it's going to take a while to get there. I think the things that are, at least from my perspective, and I want to get more folks' opinions on, and I'll create some GitHub issues for this. But it is, if folks feel like that's a bad direction and we should have a public instance of this, I don't want to take anything off the table, but at least in the beginning, I want it to be a sort of like a guiding light for people to sort of follow. And then over time, it could be something that is, hey, it's something that with very minimal configuration could be deployed to your Kubernetes platform. And then, you could just start to use, and you can plug in the things that you want or whatever. But once again, there's a lot of open questions there. Sorry, I answered your question with maybe.
Good answer. Thanks.
All right, cool. I know we're already at time. This is a ton of great feedback. I'm going to so remember there's an SSF Slack in the Open SSF Slack. Feel free to join it. We're going to have a lot of conversations there. I'm going to, based on a lot of the questions and comments here, I'm going to be creating a ton of GitHub issues, and I'll see everybody hopefully in 2 weeks.
Awesome. Thank you.
Bye-bye.
Thanks. Bye.
Bye, thanks.